Today I want to give you very basic information about dynamo. What is dynamo? We can define this way. A dynamo is an electrical device based on the principle of electromagnetic induction that converts mechanical energy into electrical energy. There are two factors we have to remember. It is based on the principle of electromagnetic induction and it converts mechanical energy into electrical energy. It is same as generator, but it is designed to produce less amount of electrical energy. That's why it is designed in such a way that it will run particular instrument. Okay, let's see its construction. Its upper part looks like a lid of the bottle and it is actually wheel. And the case is given to it, and inside the case there are certain construction. An axle starts from the wheel and goes up to the central part or more downward than that of the central part. This is axle, and at the tip of the axle there is a permanent magnet and a coil is placed very close to it. Coil means hundreds of tons of insulated copper wire is wound around the piece of soft iron and two terminals are taken out, and this is coil, and these two terminals of the wire is connected to headlight. Okay, now how it works? Actually, whenever we need light in the bicycle's headlight, then the wheel of this dynamo is made in contact with the steel rim of the rear wheel, and when wheel rotates, then this wheel also rotates, and when this wheel rotates axle rotates magnet, and when magnet rotates, then magnetic lines of force also rotates and coil cuts off the magnetic line of force, and the magnetic flux associated with the coil keeps on changing. And according to Faraday's law of electromagnetic induction, whenever there is change of magnetic flux associated with a coil, an EMF induces into the coil and current flows. And this way, current is produced in this coil and it reaches to the headlight. This way it works. Okay, now let's talk about certain conditions. What happens in the following condition? In case of this dynamo fitted in bicycle, when bicycle speeds up, this is the diagram of the dynamo. When bicycle speeds up, then what happens? The speed of rotation of the wheel becomes more, and speed of rotation of the permanent magnet will also be more, and the rate of change of magnetic flux associated with this coil increases. And according to Faraday's second law of electromagnetic induction, rate of change of magnetic flux is directly proportional to induced EMF. That's why induced EMF will be more, and because of more induced EMF, the headlight glows brightly. But in this case, when the bicycle slows down, then what happens? The wheel rotates slower, and because of this reason, permanent magnet also rotates slowly, and magnetic lines of force will be cut down by the coil in such a way that the rate of change of magnetic flux associated with the coil becomes less. If rate of change of magnetic flux is less, then induced EMF will also be less and the headlight glows less brightly. But what happens when moving bicycle is stopped? When moving bicycle is stopped, then there is no rotation in the magnet and there is no change of magnetic flux. How many magnetic lines of force are passing through this coil? It remains same. It means magnetic flux associated with the coil remains same. There is no change of magnetic flux. And if there is no change of magnetic flux associated with a coil, then no induced EMF and current does not flow and headlight cannot give us light. This way, a bicycle dynamo works.